In this video, we're going to talk about how to identify general form of the equation of a circle, and that is going to look like this top equation here. And we're going to learn how to transform general form of the equation of a circle into standard form of the equation of a circle. In standard form, we can easily identify the coordinates of the center, HK. Notice that we have opposite sign. If this is a minus here, it'll be a plus here. And if this is a minus here, of course, it would be a plus here. This is in keeping with our idea of transformations. So if you have a negative inside here, that's a right translation. A negative inside here also a right translation. And then the opposite would be true if this was a positive in both of these two places, either of these two places, it would be a left translation. And then the other feature is from the standard form of the equation, we can figure out easily what the radius of the circle is, because the number on the right-hand side of the equals is the radius squared. So we could simply take the square root of the number on the right-hand side to determine the radius of our circle. And then this form, this standard form, is easily graphed. So it's another reason why we want to see this standard form of the equation. So we take our coordinate pair for the center and plot a dot representing the center of the circle. And then we go out in our units in all directions, and we're able to draw in our circle. All right, so how do we recognize when we have a circle if we're just given this equation here? Well, the essential elements of a circle in general form, one of the skills we want to be able to develop is how to look at general form and know which conic section we have. Do we have a circle, a parabola, a hyperbola, or an ellipse? So we're just going to talk about circles right now in this video. But a circle is going to have an x squared term, a y squared term, a plus in between those two squared terms, and a and b are going to be the same number. A equals b. If all of these elements exist in the general form, we know we have a circle. So let's do a couple of examples here. Here's our first example. So let's check to see whether it is a circle. So I have my x squared and my y squared. I have my plus in between, and the coefficients are both ones, so they're equal. So that means this is a circle. Now we're going to use the method called completing the square to transform this form of the equation of the circle into what we call standard form, this form here. So the first thing we're going to do is we're going to organize our terms. We're going to put the x terms together. We're going to put the y terms together. And we're going to add the constant term or subtract it if it's the other sign to get it over to the right-hand side of the equals. So in this case, it's going to be positive. All right, so then what I'm going to do is I'm going to introduce an empty blank right there, and I'm going to do it for the y's as well. And on the right-hand side, I'm going to put 2 blanks. And that's because if you think about an equation like a balance or a teeter-totter, if I add 2 numbers, let's just call them 2's, on the left-hand side of the equation, I must add them to the right-hand side of the equation as well, because they weren't in the original equation. And I have to make sure I do that so I don't create a different equation than I started out with. So that's why we got to put balancing blanks on the right-hand side of the equals. Now let's take a step back in time here for a second, and we're going to think about a factoring idea that we've already talked about in our factoring unit, and that's the idea of how to factor what we call a perfect square trinomial. So a perfect square trinomial, for instance, looks like this, where if you take the square root of this term, so that would be x, and the square root of the last term, so that would be 2, and then you multiply 2 times both of those terms multiplied together, you should get the middle term, and we do. If that's the case, then this is a perfect square trinomial, and the factored form looks like this, where the first element, first part of our factor is x, and the second term in our factor is 2. And then this sign will go right here. Now you might recall this, but the reason this is true is because if you take x plus 2 squared, which is x plus 2 times x plus 2, you're going to get back, I'm just doing some quick distributing here, if you follow me, and prove that these two are the same. Okay, so what we're going to try to do here in order to get what we want, and remember what we want is this form. This looks a lot like that factor I just talked about, and this is what we're going to do. We're going to create a perfect square trinomial here so that I can then write it in factored form, and I'll have achieved my goal. So that's what's going on behind the scenes, if you will. So now let's go ahead and get that third number on the blank. So I'm going to find this number right here. So the technique is you take your middle term and you divide it by 2, and then you square it. So that would be 4 divided by 2 is 2. 2 squared is 4. So that gives me that number there. So I happen to have another 4 over here. So of course your center is not always going to be the same two numbers, but in this example it is. So I have a 4 here as well. All right, so now I have that factored form I was just talking about. Here it is. All right, and what I did there was I took the square root of this, that goes here. I took the square root of this, that goes here. I take this sign, and that goes here. And the same thing occurs for the y's. So we have a y, same number here. All right, this sign right here is this sign here. All right, now on the right-hand side, on the 2 blanks, since I added this 4 and this 4 into the problem when they're not really there in the original problem, I'm going to add them on this side so as not to upset the balance of my original equation. So that means on the right-hand side, if I add 4 plus 4 plus 1, I'm going to get 9. All right, so I've got now the standard form of my circle. All right, so that's one thing we wanted. Now the next thing, out of this standard form of the circle, we're going to pick out the center. The center comes from these 2 parentheses. So my center is opposite sign 2 in the x, opposite sign 2 in the y. So these are the coordinates x, y of my center. This number on the right here is the radius squared. So if r squared is 9, then I take the square root, I would get r is equal to 3. Okay, so now I have what I need. So if I put that on a graph, you're going to have the point -2, -2. There's your center. And then your radius is 3. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I'll have my circle. that's how you do it. Okay, let's take a look at this example. First of all, let's see why and if this is a circle. So I see that I have an x squared and a y squared, so good. I have a plus, so yes. Now I look at these coefficients here. They are the same, so I have a circle. And the difference with this circle is that you've got non-one coefficients. So I have a 4 and I have a 4 here. So we have to do a couple extra steps in order to get the equation to look like standard form. Notice standard form doesn't have any numbers in front of the parentheses. So somehow we have to get those numbers out of in front of the x and the y squared. Okay, so step one is we're going to organize our equation again. So I'm putting my x terms together and my y terms together. And this time I have to subtract the 25 over to the other side, which makes it negative. All right, now the next step when you have a non-one coefficient in front of the squared terms is you pull it outside the parentheses like that, which causes a distributing setup. All right, so what I've got here is a 4 times x squared. Now I want to figure out what would this term need to be such that 4 times it gives me negative 20. Well, what you can see is that if I divide negative 20 by 4, I'm going to get negative 5. Let's try that. So if I distribute now, I've got 4 times x squared, 4 times negative 5x, which gives me negative 20x. All right, so to have that 4 on the outside of the parentheses, I have to do that. All right, now I want to set up my situation that I need for completing the square, so I need that other blank. Okay, so we're going to do the same thing for the y's. I'm going to take the coefficient outside, and then I'm going to divide negative 24 by 4 to figure out what that number has to be, and then I'm going to check it. So 4 times y squared, yes. 4 times negative 6y, yes. All right, so that's good. Now I'm going to put my blank here. All right, and then of course I need my balancing blanks over here. So now we're ready to determine what I need to put on the blanks such that I get a perfect square trinomial. So again, we look at this middle term here. So I've got a 5. Now don't worry about that sign. The sign is not going to come into figuring out what goes on the blank because we square the number, and whatever sign you have there is always going to turn out to be positive. So just look at the number itself, in this case a 5. Divide it by 2 and square it. So if you end up dividing an odd number by 2, you're going to keep an improper fraction. Right? When you square an improper fraction, you square the numerator, so that's 25, and you square the denominator. So that's the number I'm going to put here. Now in the problems I'm going to give you, the fractions end up working themselves out in the end. Okay, when I talk about the right-hand side here, you'll see what I mean. All right, so then we do this one here. So this one is an even number, so we're not going to have a fraction. You square that, that's 3 squared, you get 9. All right, now what's going to be different here when you have a coefficient is that we really have a distributing situation here. We have 4 times 25 fourths that I've added into the equation, not only 25 fourths. So this is a very common error here that can be made if you're not careful. So we want to multiply 4 times 25 fourths, 4 times 25 fourths. So that's just 25. All right, so that's 25 that you're going to put over here. All right, so I distributed these two. I have to do the same here. So that's 4 times 9, that's 36. Okay, So now we're ready to write the final line of our equation. So I still have my 4 in front, but now I've got a perfect square trinomial, which I'm going to write in factored form. So the square root of x squared is x. This sign goes here, and then the square root of 25/4 brings us back to 5/2. Because we squared it to get 25/4. If we undo the square by taking the square root, it brings us back to this number here. All right, so then we have this 2, okay? Then we bring down the plus here. Then we've got the y's, same situation. The square root of y squared goes here. The negative here, and the square root of 9, which brings us back to 3, goes here, and then the little 2 for squared. Okay, now on the right-hand side, these two are going to cancel out, so you're left with a 36. Okay, one more step. We don't want this 4 here in front of the parentheses for our standard form. All right, so as we've learned, if you divide each term in an equation by a constant, you're not upsetting the equation. So I can go ahead and do that, and I'm sure that my equation is not going to be out of balance. It'll still be the original equation. All right, but that gets rid of that coefficient here. So I've got x minus 5/2 squared, y minus 3 squared, 9. All right, so that's it. We've done it. That's the equation we're looking for in standard form. So we could see that the center is opposite sign 5/2, opposite sign 3. And our radius, so r squared is 9. Take the square root of both sides. You could see r is 3. All right, so if I want to graph this, my center, so remember 5/2, of course, is the same as a 2.5, so we can use that to graph it. So 1, 2, 3, 1, 2, 3. So my center is 2.53. Okay, my radius is 3. 1, 2, 3. Let's see, 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, so that's all. We've done it. That's the second example when you have a coefficient in front of the x squared and the y squared terms, how you get the equation in standard form. The last example that I want to do is one where only one of the coordinates of the center is translated. And so the way that shows up is if I organize my terms, let's put the x's together and the y's together, put the constant, move it to the other side. What I see right here is that I don't have another y term. So if that's the case, then the y coordinate in your center is going to be 0. All right? There was no translation of the y. So you just go ahead and complete the square one time here. So I'm going to put a blank here, nothing, no blank there, and only one blank here. So looking at my center term, divide it by 2 and square it, that's 1 squared. All right, so I'm going to put a 1 over here. So then I'm ready already to complete these, to write the perfect square trinomial in factored form. So x plus square root of 1. Nothing happened to change the fact that I only have a y squared And now I have 4 plus 1, I have 5 over here. All right, so now if I write my center, I've got opposite sign -1, but I've got no translation in the y. So this is my center here. Now something else that could happen is that you won't have a perfect square for r squared. So r squared is 5 here. So what you're going to do is write your radius as an exact number, the square root of 5. Okay, now how would we figure out what that number is since we don't use calculators yet? So think about the fact that we know the square root of 4 is 2, and we know the square root of the next one up would be 9 is 3. Square root of 5 is somewhere in between these two numbers. So just to get a rough sketch going, we can say we know it's going to be in between 2 and 3. We're just going to estimate it as approximately 2.5 for graphing purposes. All right, so that's how you figure out a rough estimate of the size of an irrational number like that without a calculator. So if I'm going to graph this thing, this circle here, I know my center is at -1, 0, so that means it's right there. All right, so then my radius, we said, is 2.5 roughly. So 1, 2, 3. I'm going to go up 3 so I can get a size in here. All right, so I've got it here, here, here. That's 2.5. Sketch my circle in there, and I've got a pretty good sketch. All right, so this example here shows you how to deal with a non-perfect square on the right and one coordinate that isn't translated, so you end up with a 0 here. Could be over here. You could end up with a 0 here. And if neither are translated, your equation would be very simple. It would be just x squared plus y squared equals r squared. All right, so I don't think I've given you any that simple, but that's what's going on there. It's centered at the origin. All right, so that is all for our examples for the equation of a circle and how to get it in standard form and put it on the graph.